you for watching my video once again. My name is Mr. Charles Wenike. In this video tutorial, we are still on capacitor under electrolytic capacitors. So in this case, we stop at electrolytic capacitor in our last video, which is the electrolytic capacitors have a metallic anode convert with an oxide layer, generally used as its dielectric, which we have already discussed that in our previous video. And I also went ahead to say, and another electrode of the capacitor is non-solid and solid electrolytic capacitor. So before I proceed with that, please, if you like my video, subscribe to my channel, comment and like. Now let's start. This is where we stop on our last video so far, and we are to treat or discuss on where we stop. Now this is where we will start from this present video right now. So most of the electrolytic capacitors are polarized. Just as I said, we are still on polarized, and that polarized we have electrolytic capacitor. And in that electrolytic capacitor, I also described or I talk about aluminum, tantalum, and so on and so forth. And there are some branches that I show you which I have discussed it so far, and each of them will be discussed one by one, being one after this series of electrolytic. I will now go to aluminum. After aluminum, I will go to tantalum and so on and so forth before going to another branch called super capacitor. Because all these electrolytic capacitors, they are aluminum is under electrolytic capacitor, tantalum is under electrolytic capacitor, and niobium is under electrolytic capacitor. So that is the most thing that is why I am treating on electrolytic capacitor. I believe that this one is the second video on the electrolytic capacitors. So in that case, I also discuss on polarized, and polarized I have explained it so far, which it has positive and negative, and it must be connected accurately so that the voltage will pass through the right source and give it to the other output aspect of it. So in that case, most of these electrolytic capacitors are polarized. Polarized simply means plus and minus, negative and positive. So these capacitors are categorized according to their dielectric, which I have just mentioned before. The capacitors are categorized according to their dielectric material. Mainly, these are categorized in three classes. These are categorized in three classes. They are categorized in three classes, and those three classes is what we are going to see right here now. So in that case, first thing, we have aluminum electrolytic capacitor. Aluminum electrolytic capacitor, aluminum acts as its dielectric. Aluminum instead, it acts as dielectric. Now in that case, and now again we have tantalum. Tantalum here also, it has tantalum pent oxide. It also acts as dielectric. Just as I said when I treated on the dielectric material, I said it will be named after the name of that dielectric. If it is aluminum, it will be named aluminum. If it is tantalum, it will be named tantalum. All you need to do is to discover which of the dielectric material you are dealing with. So in that case, what I'm trying to explain here is aluminum, it will act as a dielectric and it will be given to that particular name as a dielectric name. So tantalum here is the same thing, electric capacitor, and the tantalum there also act as dielectric material. So here is niobium electrolytic capacitor, and here niobium pent oxide act as a dielectric material. because each of them will act according to their dielectric material, but they have different dimensions. They have different dimension. That dimension could be in size and in voltage rating and so on and so forth. But they are under electrolytic capacitor. So in that case, electrolytic capacitor, usually the permittivity of tantalum pent oxide is almost 3 times greater than the permittivity of aluminum dioxide. Now, but this permittivity determines only the dimension. The permittivity, the work of permittivity in capacitor is only to determine the dimensions of capacitor. The dimension of capacitor, it could be the size, just the way it is. The size or the dimension of electrolytic capacitor is different from dimension of tantalum capacitor, is also different from niobium capacitor. They have different dimension altogether. So in that case, irrespective of the permittivity, which I have already discussed the permittivity, if you haven't watched the video, go to my channel, Just Electronics. You will see what I discuss about permittivity. So usually the permittivity of tantalum pent oxide is almost 3 times greater than the permittivity of aluminum dioxide. But this permittivity determines only the dimensions of the capacitors. It doesn't change anything, it determines the dimensions. Now in that case, generally 3 types of electrolytic are used. You see, generally 3 types of electrolytic capacitors are used. They are as follows. 3 types of electrolytic capacitors are used, and they are as follows, which are non-solid. Non-solid could be wet or liquid. These capacitors have the conductivity nearly 10 meaning. Okay, I will give you the meaning of it, because this X stands for Siemens / centimeter, and these are available with low cost. 10 Siemens / centimeter. This CA stands for centimeter, and these are available with low cost. Remember, I said generally 3 types of electrolytic capacitor are used. They are as follows. Which one is solid and non-solid? Non-solid, it will be wet or liquid, and these capacitors have the conductivity nearly 10 Siemens / centimeter, and they are available with low cost. Now, just what I showed you here, this 10 mx / cm, I want you to understand the meaning of what I mean. That S, this bracket and close, that S stands for Siemens, is a unit of the electrical conductivity. That is what I just said here. This is this X here is a unit of electrical conductivity, because since it has non-solid being wet or liquid, so it has to be involved in this particular area. That is why it's there. So I want you to understand that Siemens is the unit of the electrical conductivity. The conductivity of water is measured within a certain distance. The conductivity of water is used within a certain distance. Thus, the unit is in this. There is Siemens / centimeter, or in this form, just the way it is here. Because of the conductivity of the water, which I said there's generally 3 types of electrodes are used. Three types of electrodes are used. They are as follows: which non-solid, wet or liquid. So that is why this Siemens, this 10 ms being this 10 and then mini Siemens is here. So that is the reason why. Is because of this wet or liquid. That is why is there. So in that case, the Siemens is a unit of the electrical conductivity. The is the unit of the conductivity. The conductivity of a water is measured within a certain distance. Thus, the input is in this form. Is in this particular form, SM slash CM. Siemens slash. This one is in centimeter. It can be in this form, this x slash centimeter, or it can also be ms slash centimeter. This S stands for Siemens. It is the unit of electrical conductivity in terms of the input. So in that case, solid magnets oxide, this capacitor have the conductivity nearly up to 100 Siemens slash centimeter. Also have a high quality and stability. You can see that the solid, there is one between the solid and the liquid. This one now is solid. The other one, the previous one that we have already discussed, which is non-solid. There is big difference between the non-solid and the solid one, but they also use the same Siemens in times of their unit, depending on what you want to use it, then use them for. So the solid magnets oxide, these are capacitor, have the conductivity nearly 100 Siemens or slash centimeter and have high quality and stability. Quality and stability is what you should also consider in terms of any capacitor that you are to use. You know, capacitor is very important. Capacitor is used even in our generator, in our lister, in so many things in our electronics. So as a technician or as a student or whatever thing you are doing, irrespective of where you are, if you have to substitute a capacitor, substitute the same thing that you are removing. Don't go higher or below of it, so that that equipment or whatever thing that you are working will not have an issue. So in that case, what I'm trying to say here is the solid and non-solid, they are different. This one, it has high quality and stability. Now, solid conductivity polymer. Solid conductivity polymer. I think this one is a third one, because I told you that there are three types of electrode. Three types of electrode. One is what I mentioned, non-solid. The second one is solid. Why this one is solid conductivity and solid conductive polymer. And this type of capacitor have conductivity approximately 10,000 Siemens slash or centimeter, and also has equivalent series resistance. This EXR, it stands for equivalent series resistance value of 10 mini ohms. I will also discuss on this ESR. I will discuss it in a different video for you to understand the full meaning and how it functions in each of the circuits. Either it could be any circuit at all, but also remember that in our desktop, laptop, television, ampad, or whatever thing we are using, it has equivalent series resistance, because those things, they are all embedded in each of our electronics circuit. In that case, I will make a good video on this equivalent series resistance for you to understand it very well. So from what I have just said now, this solid conductive polymer, this type of capacitor have conductivity approximately 10,000 Siemens slash or you can say slash centimeter, and also the equivalent series resistance value of 10 milliohms. So in that case, electrolytic capacitors are generally used in direct current, because this DC it stands for direct current. Generally, electrolytic capacitors are generally used in direct current, and that direct current in direct current power supply signal. They are generally used in direct current power supply signal. And direct current means DC voltage. DC voltage, it simply means that the voltage or the current goes in one way, just like that. Difference between AC and DC. AC will be converted to DC using the help of bridge rectifier. It could be single bridge, it could be 4 diode. So in that case, before electrolytic capacitor will be used, it is used in power signal, being DC power and direct current. It is not used in AC signal. So in case if you went to interview and they ask you where is electrolytic capacitor is used, you should know that it is used in direct current. It is used in direct current, mostly power supply and coupling and decoupling. We will also discuss that. So in that case, these are also used in application of coupling and decoupling to reduce a rainbow voltage. It is also used in the applications of coupling and decoupling to reduce rainbow voltage. I have already discussed this rainbow voltage as well. If you have not seen it, please go to my video. You can also watch it and understand what rainbow voltage is all about. So in that case, due to the large capacitance values and their small sizes and their small size, one of the main disadvantages of electrolytic capacitor is their low voltage rating. One of the main disadvantages of electrolytic capacitor is their low voltage rating. Why I'm putting all this in is because in case if you have been in any interview and you are asked what is one of the most disadvantages of electrolytic capacitor, is for you to know that it is a low voltage rating is the main of disadvantage of electrolytic capacitor. Thank you once again. Please, if you like my video, subscribe to my channel. See you next week. Thank you once again.